Hello, one and all present here. This is Amit Kumar Singh, and welcome to my new session on very important topic on operation research. The topic name is game theory. So, when we talk about game theory as a response to the mathematical modulation is very important. When we talk about economics, when we talk about computer science, when we talk about social science and biology, so game theory is altogether is very important topic. There's a well-known mathematician called John von John von Neumann. So this mathematician called John von Neumann. This mathematician has done remarkable work on game theory, and this game theory is all about the study of mathematical models of strategic interaction among rational decision makers, and that way when we see game theory, we can find it relevance in more or less in mathematical modulation in regard of social science or computer science, or when we talk about various discipline of biology and economics. So when we go ahead and we can remember the theory of games, the game theory. So I can still correlate game theory with well-known mathematician who got Nobel Prize in 1994. His name was John Nash. I hope you remember the movie called Beautiful Mind, A Beautiful Mind. So this movie, very good movie. If you have not seen that movie, you should definitely watch this movie. The way Russell Crowe has done the acting for John Nash, and how this mathematician John Nash, how this person came up with the theory of games, and he just revolutionized the work of John von Neumann. So there's a mathematician. His name was John Nash. You can study about John Nash to get more information about game theory. So when we talk about game theory, so game theory is basically game theory talks about the competitive situation. So when we talk game theory, what basically game theory basically do, it talks about a competitive situation in the market. So when we talk about this competitive market, so we basically talk everything in the relevance of capitalistic economy. So probably I'm not talking in the relevance of socialistic economy. I'm talking the perspective of capitalist economy. So in the capitalist economy, when different players they all work together with a common objective, then definitely there will be a competition. And when we talk about competition, competition is good for the economy. So through competition only innovations happens, and we figure out more and more research and development, and that will lead to the survival of fittest, the Darwin theory of survival of fittest. So when we talk about competition, competition is the watchword of the modern life, and we can say that in a competitive environment, there's definitely a competitive solution exists if two or more individuals they make decisions in a situation that involves conflicting interest, and in which the outcome is controlled by the decision of all concerned parties. So you can understand, you can correlate the game theory with the theory of evolution, the theory, the way we have evolved over the time, how human have become such an intelligent animal. So you can understand it all happened because of competition. So this game, when we talk about the game, it talks about a conflict between two and more parties. So when people with same interest, they will try to conflict, then definitely a better environment will develop, and in which we can talk about a situation that is called zero sum game. We can talk about a situation called zero sum game. So when we talk about zero sum game, the zero sum game is like that that in an involvement of a game theory is, if there are some loser, then definitely there are some gainer. So if we see stock market, and suppose if I'm saying that today's stock market fall down by 200 point, and we see the people face that everyone is crying because with the market had fall down and people had lost a lot of their money. So you can read in a newspaper, Economic Times and all, where you read the headline that because of the market downturn, the lot of people lost that much money. Maybe they lost X lakh crores rupees of money. So if or collectively a lot of people have lost some X lakh crores of money, then definitely there would be some people who definitely would have gained that X lakh crore rupees. because we talk about transaction here. We are talking about transaction. So there's a if there's a buyer, then there definitely there's a seller. So here we are talking about a competition environment. So when we talk about competitive environment, so it's not like there's always a winner and there's always a loser. So for every loser there is a winner. Okay, so only thing is that we sometimes, like, we only talk about winners, and we don't care about losers. So sometimes we talk about losers and we ignore the perspective of winner. So we need to see both into the consideration whenever we talk about competition, and that lays the foundation of game theory. So when we talk about game theory, a situation is termed as a game if it possesses the following properties. So you can read those properties. So those properties can be that the number of competitors in who are fighting for the same objective. That number of competitors should be finite. So there should not be infinite number of competitors fighting for the same cause. We're talking reality. We're talking the in reality point of view. So the number of competitors who are working for a given objective, they should be finite, and there should always be conflict of interest between the people, where every person who is working for this competition, that he or she have a finite set of possible course of action. So you cannot play the game with infinite set of actions with you. So we are talking a very realistic scenario. So where the people who are engaging in the competitive environment, everyone have certain set of possible course of action. Everyone knows that what kind of strategies they can play with regard to the given situation, and the rules what is there in regard of this competitive involvement. So it should be specified and should be well known to all the player, where the game begins when each player chooses a single course of action from the list of actions or the list of course of objective what they are available to them, where the objective of the game is affected by the choice which is made by all the players. So all the people, they have the finite course of homework, what they want to imply in the real world scenario, and everyone knows the rule of the game. So it's not like something which is unknown or something which is fishy. So more or less everything is more or less clear, and everyone have their own set of strategies, and those strategies what everyone have to win the given situation, that should be finite and that should be known to everyone. So where the outcome of the game is affected by the choice what the players make while working on this game theory, and where the outcomes for all the specific set of choices by all the player is known in advance, and it should be numerically defined. Then only the logic of game theory will make sense. So when we work on game theory, when we're talking about a very competitive world, where different players are working for a common objective, then the ideology with which they are working, so they're working with a strategy. So strategy is the complete set of actions. Strategy is a complete set of actions which specify precisely what the player will do under every possible contingency that might occur during the play of game. So that way the strategy will create relevance, and when we talk strategy can be a pure strategy, or a strategy can be a mixed strategy. So like probably when we talk about game theory, when we talk about probably a zero sum game, 2% zero sum game, normally we talk about game theory in that relevance only. So what we can do, we can determine the payoff of one person with respect to the other person. So probably I can give you an example. Maybe I can give you an example on game theory. Like suppose two people are playing a game. Suppose there's a player A and there's a player B. So there are two players are there, player A and player B. Okay, and this is the payoff matrix. So here, so both are playing the tossing coin. So both A and B have a coin with them, and simultaneously both are tossing coin together. If both of them will get head or both of them will get tail, then the person A will receive 1 rupee. So if both of them will get head or both of them will get tail, then the person A will receive 1 rupee. And then if both of them if both of them will either receive head or tail, then the person B will receive 1 rupee. So whenever you draw the payoff matrix in the game theory, so that payoff matrix, what you can see here, that this payoff matrix is always written in the perspective of one person. So here, by looking at this payoff matrix, you can understand. If you see this payoff matrix, so if you see this payoff matrix, 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 so this is payoff matrix is basically, this is the payoff matrix of player A. So you can easily understand this payoff matrix. What you can see, this payoff matrix is of player A, because the plus sign talks about the inflow and the minus sign talks about the outflow. So whenever the heads or tail comes, whenever the heads and tail comes, both heads and both tails come, then the A get 1 rupee, and you can see that one is written with plus sign. And whenever head or tail comes, the either head or either tail come, one person get head, other person get tail, or one person get tail, other person get head, then player B will get 1 rupee. So whenever you write the payoff matrix, you always write the payoff matrix in the perspective of one person, and then probably that one person, what we're talking about, we are talking about that person whose name is written on the left hand side, and then when you see the payoff matrix, that is always in the perspective of one person. If you really want the perspective of other person, the payoff matrix of other person, so it's very easy. You just need to understand the same thing. So this is head, this is tail, this is head, this is tail. So here this is -1, this would be -1, +1, this would be +1, and this would be -1. So here I'll write player B, and here I'll write at the top player A. So now you can easily understand. So this payoff matrix, now what you can see, this is basically the payoff matrix of player B. This payoff matrix, what you can see, this is the payoff matrix of player B. Okay. So this way you can understand the perspective of the game theory. So in the case of game theory, there are certain number of elements which are written inside a matrix. You know what a matrix and determinants, definitely would have done. You definitely would have understood a matrix and determinants. You would have studied this in your mathematics class 12 standard. Uh, so if you have doubt on matrix determinants, you can watch my video on matrix and determinants. It is there in the playlist, and you can go to the math section and you can watch my video on matrix and determinants. To get more information on matrix and determinants, you can work on adjoint, inverse, all the perspective in all that I have explained there, transpose, everything, symmetrical, is all skew symmetric, all that I have explained there. You can watch it there. Anyway, coming back to the perspective. So here we talk in the perspective of one player. So this is player A, payoff matrix, and this is player B, payoff matrix. You can understand. So whenever we talk about game theory, we talk about a game theory where the two people or more than two people, they're working on attaining a given set of output, and whenever it happens, that objective of attaining that output, whenever the people engage. Suppose if I talk about a given situation, like suppose, so you can see this payoff matrix. So you can see this payoff matrix. So you can see this payoff matrix of two player, player A and player B. Okay, this is player A and this is player B. So again, no need of me writing that. I hope you can easily understand this. So what actually happens when we work on the game theory, and the people who are engaging on the game theory, when they are working on the same set of output, everyone come up with their strategy. So the strategy is either pure strategy, or the strategy can be mixed strategy. I'll talk about pure strategy and mixed strategy maybe after 5-10 minutes. So probably let me explain you some other terms which are a little bit important as to understand the relevancy at this moment. probably pure and mixed, I'll explain you. Just you need to give me 5 or 10 minutes for that. Once I make you to understand the component like payoff and all, then probably we'll go back and we'll try to understand pure and mixed strategy. So you can understand the term called payoff. So payoff is the outcome of playing the game. You can understand the payoff. The payoff matrix is the table which shows the amount received by the player named at the left end after all the possible plays of the game. You can understand the same thing I've shown you. The same thing I've written here. So what is payoff basically? So payoff matrix is the table which shows the amount received by the player whose name is left written at the left end after all the possible plays of the game. Okay, you can easily understand the payment is made by the player named at the top of the game. Okay, fine. So I've written the same thing, player A and player B. So that the same thing I explained here. So a game with two players where the gain of one player is equal to the loss of other player is known as 2% zero sum game. A very important thing. You can easily understand this with the relevance of Nifty example, stock market example, what I've given to you. Now, when you work on game theory, we basically work on Maxi Mean principle. When we work on game theory, we basically work on the perspective of Maxi Mean principle. So, Maxi Mean principle is used for the selection of optimal strategies by two players. Okay, so consider two players A and B, where A is the player who want to maximize his gain, while B is the player who want to minimize his losses. I hope you understand what is A, what is B. So A is the player whose name I wrote horizontally, and B is the player whose name I wrote vertically, where the matrix was in favor of A, where the payoff, all the data, everything is written on the perspective of gain and losses of A. So the two players are there, and they are engaging in this war of attaining the maximum value. So where when you talk about A will suppose if you see the matrix in the perspective of A, if you see this matrix in the perspective of A, so what A will try to do, A will always try to maximize his gain, and B will always try to minimize his losses. If you can see this in the perspective of B, so all the data which is written with plus sign is actually the negative sign for B. So this is for if you see with the perspective of B, if you see this in the perspective of B, so this is actually -3, this is -4, this is -2, this is -3, this is +1, this is -1. If you see in the perspective of B, so what the B will try to do, B will always try to minimize his losses. So these are the losses for B. So what the B will do, B will try to minimize his loss. So out of -3 and -4, which is the smallest data, so B will try to minimize loss. So the smallest data is -4. Okay. So just ignore the sign here. So here the minimum data is -3. Here the minimum data is -1. So I hope you can understand this. So now let me change the perspective. So let me change this perspective. Let me show you this in the term of A. Let me show you this in the term of A. So what you will do actually mathematically to do this? What we do actually mathematically to do this? So what we do, we find here to solve this problem, we will find the column maxima. So column maxima here, this would be 4, this would be 3, this would be 1. So vertically what we do, the column wise, we find the maximal element, and because we find out the maximal element for the column wise, so for row wise, what we'll do to solve the problem, we'll find the smallest element row wise. So we find the smallest element row wise. So when we talk about row wise, the smallest element is -1, the smallest element is 1. Okay. Now, so this ideology is called as Maxi Mean principle. So when we talk about A, this matrix is favoring A. This matrix is all about the output of A. So when I talk in the perspective of A, so where A will try, A is working on his gain. So where the B will not make sure that A should get his gain. So what A will try to do, A will figure out what A can do, and A will always try to maximize his gain. So for that, for all the gains what the A have, for all the minimal data what the A have, A will try to see the data which is the biggest one. So from all the row minima, find the maximal element, that is called Maxi Mean. This strategy is called Maxi Mean strategy. So from all the minima, find the maximal value. And similarly, in the perspective of B, where you saw all the maxima data, from all the maxima, find the minimal data. So this strategy is called as minimax strategy. This strategy is called as minimax strategy. So that is what I explained you here. So this is what I explained you here. So when we talk about maxi mean or minimax principle, it is used for the selection of optimal strategy by the two player. So consider two player A and B, where A is the player who want to maximize his gain, while B want to minimize his losses. Since A would like to maximize his minimum gain, so this value is called as maxi mean value. So this value is called as maxi mean value, and the strategy is called maxi mean strategy. While on the other hand, when you talk about player B, he want to minimize his losses. When you talk about player B, he want to minimize his losses. And so the value what you got for B is called minimax value, and the strategy of B is called as minimax strategy. When both are equal, when if the maxim, if they are equal, if they will get equal, if you see that they are equal. So if you see this, if you find that the maxi mean value, if you found that the maxi mean value, if that become equal to the minimax value, if you found that is equal to the minimax value, then this kind of strategy is called as pure strategy. So then this kind of strategy is called as pure strategy. Then this kind of strategy, what you'll get, this is called as pure strategy. And when we talk about pure strategy, then the value what you get, this value of game is basically is derived at the saddle point. So this value is called a saddle point, the value at which the maximum value become equal to the minimax value. This value, what when we talk about this value, the value at which maximum value become equal to a minimax value, so that point, that value where they become equal, that is called saddle point. So we say that saddle point exists. Okay, and the value of game is always the saddle point. So for this problem, the saddle point, for this problem, when you talk about saddle point, so your saddle point is basically 1. So where the maximum value become equal to minimax value. So this value is called a saddle point. And if that they become equal, then this kind of strategy is called as pure strategy. And when they are not equal, when you don't get that attainability, that your minimax value become equal to the maximum value, then that kind of strategy is called as mixed strategy. And when we work on mixed strategy, we actually try to solve the problem by using probability. So we use probability to solve the problems which involve mixed strategy. So whenever we solve the problem which work on mixed strategy, we actually solve the problem. By using a probability. So that would be the ideal way of working on the situation, on whenever we have the situation of mixed strategy. So like you can see here, so mixed strategy, like I'll give you one example. So suppose if I give you the data, like this is 2 by 2 matrix, so 5 1 3 4. Can easily understand. This is no need of me writing again A and B. I hope you can easily understand. Okay. So this is the perspective of A, and this is the perspective of B. So the space is not there for writing B. Otherwise, I am supposed to write B at the top, at the vertical top. Okay. So here you can see the perspective of A and B. Both are engaging so that they can get the required output. Although the payoff is talking about the perspective of A, but both are engaging so that they can get the required output. So here the A is also putting effort, and B is also putting effort. So the probability of A putting these efforts, they are P1 and P2, where you know that You know that the sum of P1 plus P2 is equal to 1, and you know that Q1 plus Q2 is equal to 1. The total sum of probability is always 1. So now in order to solve this problem, so I can solve this problem writing in the perspective of A. So if I write in the perspective of A, so what are the possible strategies for A? If I write in the perspective of A, so the possible strategy of A, when I talk about possible strategies of A, if I write in the perspective of A, so the possible strategy of A, if you write, it can be 5P1 plus 3P2, or the strategy of A would be 1P1 plus 4P2, where you know that the sum of P1 and P2 is equal to 1. And the value of game, you can either determine, either you can say the value of game, either you can say that the value of game is 5P1 plus 3P2, or you can say that is equal to 1P1 plus 4P2. Similarly, if I talk about the strategy of B, similarly, if I talk about the strategy of B, so the possible strategies of B, if I talk about the possible strategies of B, if I talk about the strategies of B, so the strategy of B, if I talk about, that would be 5Q1 plus 1Q2, and that would be equal to 3Q1 plus 4Q2. This would be the strategy of B. So I can solve the problem either looking at the strategy of A or either looking at the strategy of B. It doesn't matter. I can take any one strategy into consideration to solve this problem. So if I talk about A, so I can say that 5P1 plus 3P2 is equal to 1P1 plus 4P2. So they are equal. So I can say 4P1 is equal to P2. So I can say P1 is equal to P2 by 4. And then I know that P1 plus P2 equal to 1. So in place of P1, I can write P2 by 4. So I can write 4P2 by 4 is equal to 1. So in place of P1, I can write P2 by 4. So P2 by 4 plus P2. So P2 by 4 plus P2. So that will give me the value of P2. So the value of P2 is 4 by 5. So if I get the value of P2 is 4 by 5, definitely then the value of P1 would be 1 by 5. So I got the value of P1 and P2. With that, I can find the value of game. So value of game, if I want to determine. So the value of game, if I want to determine. So it doesn't matter. You can take any equation. So if I take 5P1 plus 3P2, so this would be 5 into 1 by 5 plus 3 into 4 by 5. That would be 17 by 5. This would be the value of game. So this way, if you can solve the problem to get the answer. So in order to get the answer, you can either solve this problem in the perspective of P, or you can solve this problem in the perspective of Q also. If you want, you can solve this problem. So 2Q1 is equal to 3Q2. So you can say Q1 is equal to 3 by 2 Q2. So you got the relation between Q1 and Q2, and you know that Q1 plus Q2 is equal to 1. So in place of Q1, you can write 3 by 2 of Q2 plus Q2 is equal to 1. So you can write 5 by 2 Q2 is equal to 1. So you can write Q2 is equal to 2 by 5. So if you get Q2 equal to 2 by 5, you can find Q1 is equal to 3 by 5. And then your value of game, you can take any equation of Q to derive that. It is 5Q1 plus Q2. That is 5Q1 plus Q2. So 5Q1 is 3 by 5 and Q2 is 2 by 5. So that will give you the same answer, called 17 by 5. So when we work on a mixed strategy, when we work on mixed strategy, then there's no possibility of saddle point. When we work on mixed strategy, there's no possibility of saddle point. You can see there. You can see here. If I find the row minima here, I find the row minima here. So the row minima here is 1 or 3. Okay, and then if I find the column maxima here, if I find the column maxima here, if I find the column maxima here, so that is here 5 and 4. So so you can see here, so here out of row minima take the maximal element, that is 3, and out of column maxima take the smallest element, called 4. So they are not equal. So here saddle point and all does not work. So there's no possibility of saddle point. So there's no possibility of saddle point. And when there's no possibility of saddle point, then by using probability, we try to solve the problem. And by using probability, when we are solving the problem, that is called as mixed strategy. So a pure strategy and mixed strategy, the idea is that we need to get the required output. When we talk about optimal strategy, so the optimal strategy mixture for each player may be determined by assigning to each strategy the probability of it chosen. So this probability of it chosen, we can assign probability, and then this form of strategy what can be chosen. Ultimately, the end motive of working on the concept of maxi mean or on the concept of minimax is so that is to make sure that you can get the optimal strategy. Either it is related to saddle point or maybe it related to probability. So this is what we need to discuss in this introductory session on game theory. So probably next class we'll do more numericals with regard to game theory and all. So I hope you understood whatever I've done in this session. So with this perspective, I'm ending my session. So please subscribe to my session. Please subscribe to my videos. Please like my video. Please hit the like button for my video, and please subscribe to my channel so that whenever I do any video recording in regard of any subject, you can easily get the access of that with proper notification. So with that intention, it's time to say goodbye to all of you. Thank you everyone. God bless you.